Welcome to a comprehensive exploration of quantum mechanics, the theory that revolutionized our understanding of reality at the smallest scales. Quantum mechanics describes nature at the atomic and subatomic scales, where classical physics breaks down and reality becomes probabilistic. Let's begin with one of the most fundamental concepts, wave-particle duality. Particles like electrons and photons exhibit both wave-like and particle-like properties, depending on how we observe them. Planck's equation, E equals hf, relates energy to frequency, where h is Planck's constant. De Broglie's equation shows that wavelength equals h over momentum, revealing that all particles have wave properties. The Schrödinger equation is the fundamental equation of quantum mechanics. The time-dependent Schrödinger equation describes how quantum states evolve over time. The time-independent version gives us stationary states with definite energies. The wave function psi describes the quantum state, and its square gives the probability distribution. The uncertainty principle reveals fundamental limits on what we can know. We cannot simultaneously know both position and momentum with arbitrary precision. The product of their uncertainties has a lower bound. If we know momentum precisely, position becomes highly uncertain, and vice versa. This is not a measurement limitation, but a fundamental property of nature. Quantum systems can exist in multiple states simultaneously until measured. Before measurement, a quantum system exists in a superposition of all possible states. A quantum state can be written as a linear combination of basis states with complex coefficients alpha and beta. Upon measurement, the wave function collapses to a single definite state. In quantum mechanics, physical quantities are represented by operators. The momentum operator is negative IH bar times the partial derivative with respect to position. The Hamiltonian operator represents total energy, combining kinetic and potential energy terms. Particles can pass through energy barriers that would be impossible classically. Quantum tunneling allows particles to penetrate barriers, enabling nuclear fusion in stars and electron transport in semiconductors. Entanglement creates correlations between particles that transcend classical physics. Entangled particles remain correlated regardless of distance, with measurements on one instantly affecting the other. An entangled state cannot be written as a product of individual particle states. Let's examine a fundamental quantum system. A particle confined in a box. A particle confined in a box can only occupy discrete energy levels, demonstrating quantization. Energy levels are quantized with n equals 1, 2, 3, and so on, proportional to n squared. Angular momentum in quantum mechanics is quantized, and particles have intrinsic spin. Angular momentum is quantized with quantum numbers L and M. Electrons have spin 1/2, an intrinsic angular momentum that has no classical analog. Quantum mechanics powers modern technology from semiconductors to quantum computers. Quantum mechanics enables transistors, lasers, MRI machines, and emerging quantum computers. Different interpretations offer various ways to understand quantum mechanics. The Copenhagen interpretation involves wave function collapse, while many worlds suggest parallel universes, and pilot wave theory maintains determinism. Quantum mechanics has fundamentally transformed our understanding of reality. At the quantum level, nature is inherently probabilistic, not deterministic, as classical physics assumed. Particles and waves are not separate entities, but complementary aspects of quantum objects. The act of observation changes quantum systems, collapsing superpositions into definite states. Quantum entanglement creates correlations that cannot be explained by classical physics. From electronics to cryptography, quantum mechanics continues to drive technological innovation. Understanding quantum mechanics is essential for the future of science, technology, and our comprehension of the universe.